In this video, I'll be discussing equilibrium with solubility and Ksp. So this question says, given the following reaction showing the dissolution of calcium phosphate, calculate its maximum solubility at standard conditions. So here we have the equilibrium reaction showing solid calcium phosphate at equilibrium with its component ions, calcium ion and phosphate ion. And we're given a Ksp of 2.0 times 10 to the negative 29. Ksp is just the equilibrium constant for solubility. And the smaller the Ksp value is, the less soluble the salt is. So with an order of magnitude of negative 29, calcium phosphate is very, very insoluble at standard conditions in water. So to calculate the maximum solubility, first we need to go ahead and set up an ice table for this equilibrium reaction. So here's the blank ice table for this reaction. And the cool thing about solubility is your reactant is always going to be a solid. And remember, you don't include solids in the equilibrium expression. So for the calcium phosphate side of the ice table, you just cross everything out because we won't be needing any of these values. We're only concerned with the values of the products, which are the ions. And initially you start with a concentration of 0 for both of your ions. And over the course of the reaction, these ions increase by a factor of x. For calcium ion, it's going to increase by a factor of 3x because the coefficient is a 3 in front of calcium. And for phosphate, it's going to increase by a factor of 2x because, again, the coefficient in front of phosphate is a 2. So at equilibrium, you have 0 plus 3x for calcium ions, which is just going to be 3x, and the same deal for phosphate. 0 plus 2x is just 2x at equilibrium. So now we can go ahead and fill out the equilibrium expression for this reaction. So the generic equilibrium expression for this reaction is our Ksp is equal to the equilibrium concentration of calcium ions cubed times the equilibrium concentration of phosphate ions squared. And again, you raise these concentrations to the power of the coefficient they have in the reaction. So remember, for calcium ions it was 3, and for phosphate ions it was 2. So when you fill in our values at equilibrium into this expression, we have our Ksp, which is 2 times 10 to the negative 29, is equal to 3x cubed times 2x squared. And remember, make sure you keep these exponents outside of the parentheses, because you'll end up making algebraic mistakes if you include them in the parentheses. So just make sure you put them outside before you start simplifying this down. So let's go ahead and start doing that now and simplify this expression down in order to solve for x. So if you cube 3x, you get 27x cubed, and if you square 2x, you get 4x squared. So now we need to multiply these two terms together. So when you multiply them together, you should get 108x to the fifth. And remember, when you multiply terms with exponents, you add the exponents together. So 3 plus 2 is 5. That's where the fifth power comes from. So now go ahead and divide 108 to the other side, and then take the fifth root of both sides to solve for x. So if you take the fifth root of this term, you should get 7.14 times 10 to the negative 7, which is equal to x. So for this reaction, the maximum solubility is 7.14 times 10 to the negative 7 moles per liter. So now that you've calculated maximum solubility, you can then use that value to answer this question down here. So how many grams of calcium phosphate will dissolve in 250 milliliters of water at standard conditions? And you'll treat this question like a stoichiometry problem. So you always want to start with that volume. And we're going to go ahead and convert that volume into liters. So 0.250 liters. And then you'll take your maximum solubility. And that's 7.14 times 10 to the negative 7 moles per 1 liter. And then to get to grams, you simply take the molar mass of your salt. So in this case, the molar mass of calcium phosphate is 310.18 grams over 1 mole. And now you just do the straight math here and calculate the number of grams that will dissolve. And your answer should come out as 5.54 times 10 to the negative 5th grams. And that is how many grams will dissolve in 250 milliliters of water. So one last topic to discuss here with solubility is the common ion effect, which states that adding a solution with an ion that is common to your salt will decrease the solubility of your salt. So in our example, we had calcium phosphate. And let's say you added a little sodium phosphate to your solution. Well, sodium phosphate is going to give you the phosphate ion, and that's in common with the phosphate ion of our salt, and therefore the solubility will decrease if we added this. And that's really down to the Le Chatelier principle. If you add more phosphate, you're increasing the concentration of your products, which are your ions. And when you do that, you push the reaction in the reverse direction. And in this case, the reverse direction favors the production of the solid, which decreases solubility.